Can you guys see my screen?
Yeah, we can see it.
Awesome.
Very good.
So we're the Bleached Coral Detector group. Our AI product determines whether coral is bleached or healthy. I'm Marissa and I was our product manager.
I'm Kai and I'm a backend programmer.
I'm Brandon and I was also a backend programmer.
I'm Julio and I was a web designer.
I'm Siddharth and I was a web designer also.
And Fernanda was our mentor. Just a little bit of an intro to our product. Here are some images of our product at work. As you can see, it boxes off and detects coral as either bleached or healthy. And now I'm going to hand it off to Sid to explain our mission.
Our mission is to increase coral bleaching awareness and protection of the coral reefs by providing a product to easily identify if a coral is bleached or not. Everyone can contribute using the tool and sharing where they find bleached coral. And I'm going to give it to Julio to talk more about our cause.
Coral reefs play an integral role in our ocean's ecosystem and in our society. They not only provide the structure to our ocean's complex ecosystem, but they also provide thousands of jobs. Unfortunately, corals are at risk of suffering from coral bleaching due to global warming. We created a coral bleach detector as a way to combine our interest in machine learning and protecting the environment. Our goal is to raise awareness and track the spread of coral bleaching by crowdsourcing data. And here's Brandon with ways you can help.
Yeah, so on the bottom of our cause page, we have a footer with ways you can help. This includes volunteering in local beach cleanups, picking up your trash, using energy efficient products, choosing to eat sustainable seafood, and donating to organizations such as the Worldwide Fund for Nature and Coral Reef Alliance.
Thank you, Brandon. Now we're going to give you guys a quick live demo. On our homepage, you can click Try It Now to upload any images of coral that you'd like. And then it shows you, it identifies where the coral is and if it's bleached or not. And this image found bleached with a 98% confidence. You can try a couple more images. Here's a healthy coral. I'd just like to note that none of these images were used in the testing or training process. So these are all new images. Nicely found healthy for this one. And then here's an image which includes a healthy and a bleached coral side by side. And as you can see, it nicely identifies the healthy and bleached coral. Brandon, would you like to go into an explanation of how we did this?
Yeah, sure. So first we looked on Kaggle and UCI and the UCI repo to look for data sets, but we couldn't find any. So then we turned to Google to get images of healthy and bleached coral. We got these from like photo galleries, just some small data sets and Google Images. And then we spent like several hours using label blocks to manually label images into healthy and bleached. Overall, we drew over 2,500 labels for almost 1,000 images. The next step was the algorithm in the training. So we had to write scripts to process and manage the data. For example, we had to split the data into a train, test, and validation portions. And then we also trained the model 3 times so that we could choose the best set of weights to use.
So we're going to talk about evaluating the model. To evaluate our detector, we use confusion matrices to help iterate and improve our design. We found that we had really good accuracy when we were classifying if a coral was healthy or bleached, but where we really had a problem was a coral not being detected by the model and also some corals being detected twice. So to fix those problems, what we did was we retrained the model and we picked the best one. And we also used something called non-max suppression, which would limit the amount of boxes that would surround one piece of coral, picking the one with the highest confidence. And that helped solve a lot of the issues we were facing. We also wrote a script to save all of YOLO's predictions in image form in a folder. And we use that to help us debug more effectively so we can see exactly what the problem our model was having. We still do miss sometimes. And the reason for that is that when using our data set, like from Google, there can be a lot of artifacts like small watermarks, and that can have some influence on the accuracy. And also, we have to make sure that the coral images that you upload have good lighting. If they're too blue or too green, they might not work because we trained it on well-lit images.
Thank you, Kai. Some of our next steps. For our next steps, we would like to implement a system where users can tag their photos with the location where they found bleached coral. This way we can create like a database and a map of where coral bleaching is occurring in the world, and hopefully institutions and researchers can use this data to help solve this problem.
Difficulties we faced and lessons learned from this project. First, as Brandon said, no data sets were available about bleached and healthy coral, so we had to manually find and label our data. And by using Google to find images, we had a lot of duplicates in our data. And second, we learned a lot more about bleached corals while researching for this project. And next, like in any programming, we had a lot of debugging. This showed us the importance of organization so that we were able to find mistakes such as a missing bracket easily. And lastly, it was a team project, so we learned a lot about teamwork, such as communication and properly allocating the work so that we were able to finish this project as efficiently as possible.
Thank you for listening.